It's another exciting day here in Algebra 2. We are going to be looking at two of our parent functions today, quadratic and square root, and we are going to be focusing on some of their key features and transformations. So we are going to start with a quadratic parent function, that is x squared. So if I wanted to know what that parent function looks like, I could make a table to plot some points on the graph and connect the dots. So one input for x I could have is 0. 0 squared is 0, so I know I have a point 0, 0 on my graph. If x is 1, 1 squared is 1, so I know I have the point 1, 1 on my graph. If x is 2, 2 squared is 4, so I have a point 2, 4. And then another one that I can fit is 3 squared, which is 9. So I have those points, and then I can also do negative x values. Negative 1 squared is positive 1. Negative 2 squared is positive 4. And negative 3 squared is positive 9. So now that I have all of those points, I can connect the dots. And here is my quadratic parent function. We call that shape a parabola. And now let's go ahead and describe the key features of that graph. Its domain is all real numbers. We don't have any restrictions, so I can either use that all real number symbol, or I can say negative infinity to positive infinity. My range, my y values, start at 0 and go up in the positive direction. So we have all values greater than or equal to 0. And then if I wanted to do that interval notation, I could do this as well. Either is acceptable. Now, as far as minimum or a maximum goes, when we have a parabola opening upward, that vertex is a minimum, so I don't have a maximum. And that minimum y value is 0. X-intercept, where we cross the x-axis, is 0, 0. Same for our y-intercept. A quadratic does not have an asymptote, but it does have an axis of symmetry, and that is this vertical line that goes through my vertex. If I were to rotate it or fold it in half on itself, it would all line up. So that axis of symmetry, again, this vertical line through my vertex, and for this one, that is x equals 0. We are increasing when we're walking uphill, and that starts at when x is 0 until positive infinity. And then we are decreasing when we're walking downhill, and that is over here from negative infinity until 0, where it changes directions. So those are the features of my parent function. We are now going to look at what happens when we transform our parent function. So based on the formatting of your equation, we can describe what is being changed exactly. So we can do dilations, vertical, where we multiply by a value outside, or horizontal, where we multiply by a value inside. We can also shift left and right. If we subtract a value inside, we're shifting to the right. If we add a value inside, we're shifting to the left. We can also shift up and down. That's when we add a value outside for up, subtract a value outside for down. And the last type of transformation is a reflection. We can reflect over the x or y axis by applying a negative. When the negative is outside, we're reflecting over the x-axis. When the negative is inside, we're reflecting over the y-axis. So we're going to look at these three, and if you just look at, remember, your parent function, y equals x squared. That is what we are starting with. Now, what looks different on this first one? Well, I have a plus 8 and a minus 5. Those are new. So what exactly are those transforming? Well, plus 8 on the inside, that is going to be a horizontal shift, and because it's positive, I know I am going to the left that many, so I'm going to the left 8. Then that minus 5 on the outside means I am shifting vertically, and because it's negative, I am going down, and that would be down 5. Okay. On to the next one, I have 1, 2, 3, 4 changes happening here. Keeping in mind the negative and the 3 are two separate transformations. The negative is a reflection, and because it's on the outside, that means I am reflecting over the x-axis. Then the 3 is another transformation, and that's going to be a dilation. Because I'm multiplying outside, it's a vertical dilation. And that's by a factor of 3. Then the plus 5 on the inside is another horizontal shift. Because it's positive, that means I am going to the left 5. And then that minus 2 on the outside is a vertical shift. Because it's negative, that means I am going down 2. Okay, and then on this last one, we have two changes. We have another negative, which means a reflection. This time the negative is inside, so we are reflecting over the y-axis this time. And then that +4 on the outside means we are shifting vertically because it's positive. I know I am going up 4. So that is a description of what is happening. Now let's look at the graphs of those transformed functions and see what changes about our key features. So what I am going to do is pull up Desmos. Okay, so here is Desmos. What I have graphed right now is our parent function, x squared. And what I'm going to graph on the same grid is that first transformed function, x plus 8 squared minus 5. So what we are looking at to compare here is from the black graph, that was our parent function, to the blue graph. So remember we shifted left 8 and down 5. So the domain for this one is still all real numbers. But my range, my y value now, it no longer starts at 0. It starts down here at -5 and does go positive. So my range is all values greater than or equal to -5. We still have a minimum because our parabola is opening up, but that minimum y value is now -5, and we don't have a maximum. We do have two x-intercepts now, and I'm just going to rewrite this because it looks a little funny. -5. We do have two x-intercepts now, and if you click on here in Desmos, it will tell you we have one at -5.760 and another one over here at -10.24, 0. Okay, y-intercept, I'm going to have to find that. I'm going to go way up here because it is up high, and again, clicking on it, it will tell me my y-intercept is at 0.59. Okay. Still don't have an asymptote because that's not a feature for a quadratic, but we do have an axis of symmetry, and again, that goes through my vertex, which is now here at -8, -5. So that vertical line here for my axis of symmetry is now x equals -8. Increasing, we are walking uphill starting where x is -8 and going to positive infinity. And then decreasing, we start at -infinity and change direction at -8. So that is what changes based on those transformations. Okay, I'm going to move on to our next one, and I'm going to replace this with our second transformed function. Okay, and so we are still looking at the blue graph compared to the black graph. Domain, still going to be all real numbers. And our range, our y values now start here at -2, and they go down into the negative range. So we're going to have y values less than or equal to -2. And now this parabola is open upside down. So this vertex is no longer a minimum, but it is a maximum. So we don't have a minimum, and our maximum y value is now y equals -2. And then we are below the x-axis, and it's never going to flip back up. So we don't have any x-intercepts. I can go down to find my y-intercept, and it is going to be somewhere in here at 0, -77. Still no asymptote. My axis of symmetry, I need to go back. Again, vertical line going through that vertex. That's going to be x equals -5 here. And now for this parabola, we are starting increasing from -infinity until -5, where we switch direction. And then it goes downhill decreasing, so from -5 to infinity. Okay. Last one, I'm going to replace this with our final function. There we go, and then +4. Okay, so again, looking at the blue graph compared to our black graph, our domain is still going to be all real numbers. Our range, our y values now start up at 4, and they do go positive, so y is greater than or equal to 4. We are opening upward again, so we have a minimum, and that minimum y value is 4. no maximum. We are above the x-axis, and it's never going to flip upside down again, so we have no x-intercepts. And then we can see our y-intercept right there, 0, 4. Still no asymptote. Our axis of symmetry through the vertex vertically is going to be x equals 0 again. And then increasing, that is from 0 to infinity, positive infinity, uphill, and then decreasing downhill from negative infinity to 0, where we change directions. Okay, so that is the new features for our transformed functions, and I'm going to go ahead and cut this video off here and do our square root video in, or our square root notes in a separate video.